Hey guys, good evening and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great. So my dear students, quickly before starting this particular session, let me know once if I'm perfectly audible and visible to every one of you. Just let me know in the chats with the thumbs ups everyone if all of you can hear me properly, if I'm perfectly audible and visible to every one of you. Quickly in the chats. Welcome back everyone, welcome back. Welcome back again to your Unacademy NEET English channel. Welcome back. So quickly give me some thumbs ups in the chats people, everyone. I would want you guys to give me certain thumbs ups so that I'll get to know that I am perfectly audible and visible to every single guy. Yes? So as you all must be knowing, tonight this is going to be our first session of the Achievers batch. And my dear students, today I'll be starting with the first chapter of your class 11th chemistry. I'll be exactly starting from the basics, right? And the name of the chapter is going to be the epic mole concept, right? The chapter which most of the NEET aspirants hate actually, because it is considered to be a tough chapter basically, because it involves the calculations, right? It involves mathematics, it involves common sense, right? So majority of the NEET aspirants, they find this particular chapter comparatively tough, right? But my dear students, as I have told you already, I'll be exactly starting from the basics. We'll first cover all the theory, then different types of problem patterns which can be asked in from a particular concept. Every single thing I'll be doing here with all of you, right? It is just I would want all of you to be involved properly in the chats. Whatever I'll be asking you, I would want all of you to write the answers continuously in the chats. So all of you are ready for the session? Quickly give me the thumbs ups again so that we can start the session directly. Just give me a second. Just give me a second. Quickly let me know in the chats people if all of you are super duper excited about this particular session. Quickly everyone in the chats. Yes? Everyone. And the duration of the session is going to be 1 hour 30 minutes approximately. And right after this session, there is one more session scheduled for me at 9 p.m. Please and please do join that particular session as well. The ones who are the part of Avengers batch, right? Or the ones who have not enrolled into the Avengers batch yet, please do join me at 9 p.m. today. That's going to be one important session for all the students. Okay? Yes, Venthan, all the queries, everything I'll be discussing with you at 9 p.m. session, right? Okay, let's focus on this particular session now. Perfect. So let's get going. Let's get started with the first chapter of your class 11 chemistry. That is the mole concept. One thing which I would want to share before starting the mole concept. This chapter is the most important chapter as far as your physical chemistry is concerned, because it forms the basis of your entire physical chemistry. Do remember, if your mole concept is strong, that means automatically your entire physical chemistry will become strong. If there are doubts in mole concept, if this chapter is weak, that means your entire physical chemistry is going to be weak. So make sure you make this chapter as strong as possible, right? Okay? So before starting this particular session, the ones who have not liked the session yet, please and please do like the session. Please and please do share this particular session with everyone whosoever is preparing for either NEET 2024 or even 2025. This particular session is for every single guy, because I'll be exactly starting from the basics. And the ones who have not subscribed to the channel yet, please and please do subscribe to the channel, right? Do show the same love which you have been showing from past 1 month since we created this channel. Okay? Perfect, guys. So let me first of all show you the table of content, the topics which we are going to cover in the today's session, right? Basics of the mole concept we are going to do in the today's session. So first of all, we shall be starting with a very basic thing, that's atomic mass. After doing the atomic mass, we'll be covering the molecular mass. Then we'll see different types of questions which can be asked from molecular mass. After that, there is a term called as molar mass, and average atomic mass of an isotopic mixture. These are basically the 4 important topics which we are going to cover in the today's session, my dear students. Okay? And one thing, I would want all of you to take a note of every single thing, whatever I'll be mentioning on the screen. Yes? Perfect? Perfect, people? All right. Just a second and let's start. Just a second, guys. Perfect. Perfect then. So the first topic which we'll be covering here, that is the atomic mass. So let's start with the term atomic mass. My dear students, first of all, I'll be writing one simplest definition of the term atomic mass. The simplest definition I'll write first, then I'll make you understand the actual definition of atomic mass. Okay? So what is the simplest definition of the term atomic mass? Atomic mass, it's basically defined as the mass of single atom of an element. The mass of single atom of an element is something which we call as the atomic mass. Now, what is meant by this? Whenever from now onwards you'll hear the term atomic mass, that means we are talking about the mass of one atom of an element. For example, I'm quoting a statement, atomic mass of nitrogen. What does it mean? It means I am talking about mass of one atom of nitrogen. If I say atomic mass of sodium, that means I am talking about the mass of one atom of sodium. Atomic mass of fluorine, that means I am talking about mass of one atom of fluorine. So in simpler words, if you want to define the term atomic mass, it is simply defined as the mass of single atom of an element. That's all. This is the simplest definition of the term atomic mass. Now, dear students, before going into the actual definition of the atomic mass, let's try to understand some basic things, then we'll go into the actual definition of atomic mass. Okay? Understand exactly what I'm going to say. For example, let's say this is one object which you are taking into consideration right now. Let's say this is an iron block. Let's say it's an iron block, right? Let's assume the weight of this particular iron block is 10 kilograms. I just want you to understand certain basic things, okay? For example, I have got one more iron block over here, which is comparatively bigger in size, and I'm assuming the weight of this iron block is 20 kilograms. Now, if I ask you a general question, what this 10 kilogram means and what this 20 kilogram means. If I ask you what this 10 kilogram means, what this 20 kilogram means, how you are going to answer this? Have a look. First thing, this 10 kilogram over here, I can write it as 10 multiplied by 1 kilogram. Absolutely. I can write this 10 kilogram in this manner, 10 multiplied by 1 kilogram. In the similar way, this 20 kilograms, I can write it as 20 multiplied by 1 kilogram. Absolutely, I can write it like this. Now, you must be thinking, why did I split this term? Why did I split this term? What is the reason for that? One thing I wanted you guys to understand. And what is that? Have a look. Since this is the iron block whose weight is 10 kilograms, can I say this particular iron block is 10 times heavier than 1 kilogram? Absolutely, I can say that. Can I say this particular object, this particular iron block, it is 20 times heavier than 1 kilogram? Absolutely, I can say that. This iron block is 10 times heavier than 1 kilogram. This particular iron block, it is 20 times heavier than 1 kilogram. My weight is, for example, 80 kilograms. What does that mean? That means I am 80 times heavier than 1 kilogram. So can I say, basically, I am comparing the masses of different objects with this 1 kilogram here? Absolutely, I'm comparing the masses of different objects with 1 kilogram. So what do I call this 1 kilogram here as? Can I say this 1 kilogram with which I am comparing the masses of different objects? Can I say this 1 kilogram is our standard here, is our reference here with which we are comparing the masses of different objects? Absolutely. So this 1 kilogram over here, it is our standard with which we are comparing masses of different objects. Like I said, I am 80 times heavier than 1 kilogram. This object is 10 times heavier than 1 kilogram. This object is 20 times heavier than 1 kilogram. So in short, I am comparing the masses of different objects with 1 kilogram. So this 1 kilogram here, it is our standard, it is our reference with which we are comparing the masses of different objects. As simple as that, right? Now, my dear students, in chemistry, we deal with atoms, we deal with molecules, we deal with compounds, right? In chemistry, we deal with atoms, we deal with molecules, we deal with compounds. So don't you think in chemistry, there should be a standard like this 1 kilogram? Don't you think in chemistry, there should be a standard like this 1 kilogram with which we are going to compare the masses of different atoms or molecules? Right? In chemistry, we definitely need a standard like this 1 kilogram with which we can compare the masses of different atoms or molecules. Now, our first priority is to make that standard in chemistry with which we shall be comparing the masses of different atoms or molecules. Right? Now, my dear students, let's make that standard in chemistry first. Whatever doubts you'll be having in between, I'll be answering all your doubts at the end. First, you need to focus. Okay? So what are we going to do now? What are we guys going to do now? We are going to make a standard in chemistry. Okay? All right. So let's try to make that standard. In order to make that standard, make that reference in chemistry, I will be taking a carbon 12 atom. For example, this is your carbon 12 atom. Let's say this is your carbon 12 atom. Now, my dear students, what exactly I will be doing? I'll be dividing this carbon 12 atom into 12 equal parts. I divided the carbon 12 atom into 12 equal parts. After dividing this carbon 12 atom into 12 equal parts, if I take one part of it, can I say this shaded part, its mass is going to be 1/12. Its mass is going to be 1/12 the mass of whole carbon 12 atom. Absolutely. What exactly I did? I took a carbon 12 atom. I divided the carbon 12 atom into 12 equal parts. Now I'm taking one part of it. I'll say this shaded part, its mass is going to be 1/12 of the mass of whole carbon 12 atom. Absolutely 1/12 of the mass of whole carbon 12 atom. Right? Now, dear students, let me tell you one important thing. This 1/12 of mass of carbon 12 atom, this 1/12 of mass of carbon 12 atom, you can call it as 1 AMU, or you can call it as 1 U, or you can call it as 1 D. Let me tell you, this particular AMU over here, it stands for the atomic mass unit. This U over here, it stands for the unified mass. And this particular D over here, it stands for Dalton. It stands for Dalton. So again, I'm telling you, I took a carbon 12 atom. I divided the carbon 12 atom into 12 equal parts. Now this shaded part, its mass is going to be 1/12 of the mass of carbon 12 atom. Now this 1/12 of mass of carbon 12 atom, either you can call it as 1 AMU, or you can call it as 1 U, or you can call it as 1 D. AMU stands for atomic mass unit, U stands for unified mass, and D stands for Dalton, right? One more thing which I would want to share with you right now. What is that? Have a look. My dear students, what scientists exactly did, they used a technique called as mass spectrometry. What scientists exactly did, they used a technique called as mass spectrometry. By using the technique called as mass spectrometry, they calculated the mass of whole carbon-12 atom. And the mass of whole carbon-12 atom was found out to be 1.99 into 10 raised power minus 23 grams. What scientists did? They used the term mass spectrometry. With the help of mass spectrometry, they calculated the mass of whole carbon-12 atom. And the mass of whole carbon-12 atom came out to be 1.99 into 10 raised power minus 23 grams. Now, if I ask you, what did we do in the beginning? We took a carbon-12 atom. You know the mass of whole carbon-12 atom now. What did we do after that? We divided the carbon-12 atom into 12 equal parts. Now, if you know the mass of whole carbon-12 atom in grams, can you let me know what is going to be the mass of this shaded part in grams? You should be able to answer this. See, mass of whole carbon-12 atom is 1.99 into 10 raised power minus 23 grams. I'm asking you the mass of shaded part. That means you have to divide this term by the number 12. When you divide this term by the number 12, you'll get the value exactly as 1.66 into 10 raised power minus 24 grams. Now, my dear students, if I ask you whether this 1.66 into 10 raised power minus 24 grams, whether this is the mass of whole carbon-12 atom? No. This is the mass of the shaded part. This is the mass of the shaded part. What is the mass of whole carbon-12 atom? The mass of whole carbon-12 atom is 1.99 into 10 raised power minus 23 grams. Whatever I said till now, let's try to summarize this in one simple statement. Let's try to summarize it in one simple statement. And what is that statement? Let's have a look. Understand. I'm writing a statement 1 AMU. You can represent it with 1U or you can call it as 1D. It is just the terminologies are different, the meaning is same. Okay? How did we define this 1 AMU? 1 AMU we defined as the 1/12 of the mass of carbon-12 atom. Right? We got to know mass of 1 AMU in grams. How much that is? That is 1.66 into 10 raised power minus 24 grams. Correct? One more thing. My dear students, every one of you must have heard about the term Avogadro's number, which is represented by Na. And its value you must be knowing. It's 6.022 into 10 raised power 23. Now, what exactly I'll be doing? Let me tell you, if you divide 1 by the Avogadro's number, if you divide number 1 by this number, if you divide 1 by the Avogadro's number, you'll be exactly getting the value as 1.66 into 10 raised power minus 24. So, basically, instead of this whole term, you can just write 1 divided by Avogadro's number. The choice is all yours. The choice is all yours. Perfect. This is one very, very, very important statement which I would want you guys to remember from now onwards. One very, very, very important statement which all of you should be remembering from now onwards. So from now onwards, whenever I use the term 1 AMU, what is 1 AMU? It is 1U, it is 1D, it's 1/12 of the mass of carbon-12 atom. And this 1/12 of the mass of carbon-12 atom, this AMU, this D, this U, it is our reference, it is our standard in chemistry with which we are going to compare the masses of different atoms, the masses of different molecules. So whenever from now onwards, I will have to calculate the mass of an atom, I'll be comparing the mass of an atom with 1 AMU. I'll be comparing the mass of the molecule with 1 AMU. We'll exactly see how many times an atom of an element is heavier than 1 AMU. We'll see how many times a molecule is heavier than 1/12 of the mass of carbon-12 atom. That's 1 AMU. So this 1 AMU is our standard. From now onwards, if a question comes, what is the standard while calculating the masses of atoms or molecules? The standard is not the carbon-12 atom. The standard is 1/12 of the mass of carbon-12 atom. That is the standard. So first thing which I would want all of you to remember from now onwards. Let me know once in the chats if every single thing is clear till here. Quickly. Quickly, my dear students. So standard is 1 AMU. That is the standard, okay? Now, dear students, if you got the things still here, let's try to make it a little more clear. For example, I'm writing a statement. The statement is very simple. I'm writing atomic mass. I'm writing atomic mass of nitrogen. Atomic mass of nitrogen. What does that mean? Atomic mass of nitrogen. What does that mean? That means I'm talking about the mass of one atom of nitrogen. That means I'm talking about the mass of one atom of nitrogen. And all of you must be knowing the mass of one atom of nitrogen, it is just equaled 14 AMU. This is the mass of one atom of nitrogen. Now, if I ask you what does it mean, what this 14 AMU means, what you'll be simply doing, you'll be again splitting it as 14 multiplied by 1 AMU. Or instead of 1 AMU, you can write 1/12 of the mass of carbon-12 atom, right? Or even instead of 1 AMU, you can write 1.66 into 10 raised to the power minus 24 grams, right? Or even instead of 1 AMU, you can write 1 divided by Avogadro's number in grams. Now, if I ask you, what is the meaning of all these things which I wrote over here? I want to calculate the atomic mass of nitrogen. I want to calculate the mass of one atom of nitrogen. And mass of one atom of nitrogen comes out to be 14 AMU. That means one atom of nitrogen is 14 times heavier than 1 AMU. That means one atom of nitrogen is 14 times heavier than 1/12 of the mass of carbon-12 atom. This particular term, this is the mass of one nitrogen atom in grams. Even this is the mass of one nitrogen atom in grams. I hope every single thing is clear to you. One more similar statement I'll be writing, and you guys are going to let me know the meaning of all those statements, which I'll be writing now. Okay, this was our second statement. Now talking about the third statement. Similar statement I'll be writing, and you will be letting me know the answer of that in the chats. For example, I'm writing the term atomic mass of oxygen. Can you let me know what does it mean? Atomic mass of oxygen, what does it mean? Can I say it just means the mass of one atom of oxygen? Absolutely. My dear students, do you know what is the mass of one atom of oxygen? You must be knowing, right? It is 16 AMU. Now, can I split the 16 AMU into two parts? Can I write it as 16 multiplied by 1 AMU? Absolutely, I can do that. Instead of 1 AMU, can I write 1/12 of mass of carbon-12 atom? Absolutely, we can do that. Instead of 1 AMU, can I write 1.66 into 10 raised to the power minus 24 grams? Absolutely, we can do that. Instead of 1 AMU, can I write 1 divided by Avogadro's number in grams? Yes. Now tell me the meaning of all these things which we wrote here. Tell me the meaning of all these things which we wrote here quickly. Quickly, my dear students, tell me the meaning of all these things. Tell me the meaning of all these things. Quickly in the chats. I just wanted to know the atomic mass of oxygen. I just wanted to know the mass of one atom of oxygen, which came out to be 16 AMU. That means one oxygen atom is 16 times heavier than 1 AMU. One oxygen atom is 16 times heavier than 1/12 of mass of carbon-12 atom. This particular term, it is the mass of one oxygen atom in grams. Even this particular term, This is the mass of one oxygen atom in grams. So my dear students, after knowing all these details, can you define the term atomic mass now? You should be able to define the atomic mass now. You should be able to define the atomic mass now. Let me know quickly in the chats, what do you think exactly atomic mass is? Quickly, let me know in the chats, what do you guys think the term atomic mass is? Quickly in the chats. Quickly in the chats. Everyone. Every one of you. Every one of you. Quickly in the chats. So dear students, I can define atomic mass in one more way. I can say atomic mass I can say atomic mass is a number. Atomic mass is a number like 14 in case of nitrogen, 16 in case of oxygen, 23 in case of sodium. Atomic mass is a number which gives us an idea, of how many times, an atom of an element is heavier than 1 AMU. Just let me know quickly in the chats with the thumbs ups if this particular definition is clear to every single guy. Let me know quickly in the chats if this particular definition is clear to every single guy. Quickly in the chats, my dear students. Everyone in the chats, quickly. Atomic mass, it's a number. 14 in case of nitrogen, 16 in case of oxygen, 23 in case of sodium, 19 in case of fluorine. It is a number which tells us how many times an atom of an element is heavier than 1/12 of mass of carbon-12 atom. That's 1 AMU. Quickly in the chats with the thumbs ups. Everyone, quickly. Everyone, quickly. So I hope your first terminology, that's atomic mass, is clear to everyone. Yeah? I hope this particular definition, both the definitions are clear. Okay? Now, dear students, let's move on to one more term, one more basic term. That's molecular mass. Atomic mass is defined for the atoms basically, right? Molecular mass will be defined for molecules, as simple as that. So what is molecular mass? How do we calculate the molecular mass basically? Let me tell you that. I'll write its definition first, then I'll make you understand. Molecular mass, it is the sum of atomic masses. It is the sum of atomic masses of all the elements. It is the sum of the atomic masses of all the elements present in a molecule or a compound. What does that mean? Let's have a look. Understand properly. My dear students, for example, I'm talking about, for example, ozone. You would have heard about this particular term, ozone. Do you know the molecular formula of ozone? Molecular formula of ozone, it's O3. Molecular formula of ozone, it's O3, right? Now, dear students, if I want you to calculate the mass of one molecule of ozone, till now we were talking about the atoms. Now I'm asking you, what do you think is the mass of one molecule of ozone? Mass of one molecule is something which you call as molecular mass. So indirectly I'm asking you, calculate the molecular mass of ozone. If I ask you calculate the molecular mass of water, that means indirectly I'm asking you, calculate the mass of one molecule of water. Calculate the molecular mass of carbon dioxide. What does that mean? That means calculate the mass of one molecule of carbon dioxide. I hope you are getting everything. Now, how do we calculate it? How do we calculate it? The sum of atomic masses of all the elements. Very simple and basic. Ozone, since you know its molecular formula, in one molecule of ozone, there are 3 oxygen atoms. What is the mass of one oxygen atom? That is 16 AMU. How many oxygen atoms are there? 3 oxygen atoms. The value comes out to be 48. Now either you can write AMU, or you can write U, or you can write D. The choice is all yours. But in case of molecules, we prefer the term U. Now can you let me know what this 48U means? Can I split this 48U in this manner? 48 multiplied by 1U. Instead of 1U, can I write 1/12 of the mass of carbon 12 atom? Right? And instead of 1U, can I write 1.66 into 10 raised to the power minus 24 grams? And instead of 1U, can I write 1 divided by Avogadro's number? Now you tell me the meaning of all these things. I wanted to calculate the molecular mass of ozone. I wanted to calculate the mass of one molecule of ozone. And the mass of one molecule of ozone came out to be 48U. That means one molecule of ozone is 48 times heavier than 1U. One molecule of ozone is 48 times heavier than 1/12 of the mass of carbon 12 atom. This is the mass of one molecule of ozone in grams. Even this is the mass of one molecule of ozone in grams. Right? Right, my dear students? I hope this is super clear to you. Let me take one more example. Let's say I'm taking, for example, methane into consideration. CH4. Simple molecule. CH4, methane I'm taking. I want you to calculate the molecular mass of methane. I want you to calculate the mass of one molecule of methane. How exactly you're going to do it? In case of methane, there is 1 carbon and 4 hydrogen atoms. What is the atomic mass of carbon? That's 12 AMU. How many carbon atoms are there? 1 carbon atom plus hydrogen. Its atomic mass is 1 AMU. How many hydrogen atoms are there? 4 hydrogen atoms. Just calculate it. The value comes out to be 16U. Now, you know what the 16U means. It is the mass of one molecule of methane. One molecule of methane is 16 times heavier than 1U. One molecule of methane is 16 times heavier than 1/12 of mass of carbon 12 atom. What is the mass of one molecule of methane in grams? It will be 16 multiplied by 1.66 into 10 raised per minus 24 grams. Or it can be written as 16 multiplied by 1 by Avogadro's number. As simple as that. Yes? Perfectly done. Perfectly done, my dear students. Take one more case. Let's say you have got NH3. Calculate its molecular mass. Nitrogen, its atomic mass is 14. There is 1 nitrogen atom. Hydrogen, its atomic mass is 1. There are 3 hydrogen atoms. Just solve it and get the value. The value comes out to be 17U. This is the mass of one molecule of NH3. One molecule of NH3 is 17 times heavier than 1U. One molecule of NH3 is 17 times heavier than 1/12 of mass of carbon 12 atom. One molecule of NH3, what is its mass in grams? 17 multiplied by 1.66 into 10 raised per minus 24 grams. I hope this is super clear to you. I hope this is super clear to you. Yes? I hope this is super clear to you. Quickly in the chats. Right, my dear students? Right? Everyone in the chats? One more molecule, then I'll move ahead. For example, you have got H2SO4. H2SO4, calculate its molecular mass. Hydrogen, its atomic mass is 1. There are 2 hydrogen atoms. Sulfur, its atomic mass is 32. There is 1 sulfur atom. Oxygen, its atomic mass is 16. There are 4 oxygen atoms. When you solve it, the value comes out to be 98U. So this is the molecular mass of methane. Sorry, this is the molecular mass of H2SO4. One molecule of H2SO4 is 98 times heavier than 1U. Everything you can calculate now, right? So if I ask you to define the molecular mass, will you be able to define the term molecular mass? You should be. Molecular mass is again a number. Molecular mass is a number which tells how many times a molecule is heavier than 1/12 of the mass of carbon to an atom. I hope this is again super clear to you. This is your definition of the term molecular mass. This is the definition of the term molecular mass, right? Let me make you understand few more things. Let me make you understand few more things. Have a look, people. Have a look and understand carefully. Understand carefully. Take any element of your choice. Take any element of your choice. The very common element which we have been dealing with, that's oxygen, nitrogen, fluorine, right? Let's say I'm talking about nitrogen. I've taken an element nitrogen, right? I've taken an element nitrogen. Understand what I'm going to tell you now. For nitrogen, you know, its atomic number is 7 and its atomic mass is 14. You know it, correct? Now, over here, I'm going to write three things. Three things I'll be writing. And you have to differentiate all the three things. The first term which I'm writing, that's 14 AMU. The second term that I'm writing, that's only 14. The third term which I'm writing, that's 14 multiplied by 1.66 into 10 raised power minus 24 grams. If I ask you whether the meaning of all these terminologies is same or different, let me quickly tell you that. This 14 AMU over here, you are going to call it as the atomic mass of nitrogen. This 14, you will be calling it as a relative. You'll be calling it as a relative atomic mass of nitrogen. And this particular term over here, you'll be calling it as the actual mass of nitrogen. You'll be calling it as the actual mass of nitrogen. Do remember these three things. 14 AMU, 14 multiplied by something, right? These are the terminologies. Yeah? You can call it as the actual mass or absolute mass, as simple as that. Okay? One more example I'm giving you. Let's say I'm talking about sodium. Whose atomic number is 11. This is 23. Now I'm writing few things about sodium. First term, I'm writing 23 AMU. Then I'm writing only 23. Then I'm writing 23 multiplied by 1.66 into 10 raised power minus 24 grams. You need to differentiate all the three terms here. This 23 AMU, you will be calling it as the atomic mass of sodium. This 23 only, you will be calling it as the relative atomic mass of sodium. And this particular term, you'll be calling it as the actual mass of sodium. You'll be calling it as the actual mass of sodium. I hope this is super clear to everyone. I hope this is super clear to everyone, right? Now, if these things are clear, if these two things are clear to you, let me tell you one more thing then. If these things are clear to you till now, then let me tell you one more thing, okay? Let me tell you one more thing. Just have a look what I'm going to tell you now. Okay. For example, let me not take the atom now. Let me take a molecule. For example, which all molecules did we take? We took CH4 in the beginning, right? We took CH4 in the beginning. For example, I'm taking CH4 only. CH4, correct? Now for this CH4, again I'll be writing three terms. You have to differentiate them. One is 16U, another is 16, and the last one is 16 multiplied by 1.66 into 10 raised power minus 24 grams. You have to differentiate these three things. Just differentiate them quickly. Just differentiate them. The 16U, do I call it as the atomic mass? Look here, it's not the atom, it's molecule. So this is the molecular mass, right? This is the molecular mass because the given species is a molecule. The 16, should I be calling this as a relative atomic mass? No, you will be calling it as a relative molecular mass. Relative molecular mass. This particular term, what you should be calling it? The same, actual mass. Actual mass. I hope it's super clear to everyone. I hope it's super clear to everyone. Just let me know once in the chats. Let me know once in the chats. Akansh, just focus on the session. You have got nothing to do with what you're asking, right? That's my personal choice. Please focus on the session. Only thing that matters to you is the content which I'm providing here. Right? I hope you got it. So quickly, let me know in the chats if every single thing seems clear till here. Right, people? Perfect? Perfectly done and dusted? It should be. It should be. Perfect. Now, if the term molecular mass is confirmed, now let's move on. Let's move on to certain questions first. Let's move on to certain questions. Look at the question carefully. Look at the question carefully. Look at the question carefully. Will you be able to solve this quickly in the chats, everyone? Quickly. Will you be able to solve this one? Let me show you how do we approach these sort of questions. Look at the question carefully and remember the approach, how we are going to solve them. Okay? As far as the question is concerned, if 1U is defined as 1/24th of the mass of carbon to an atom, just write the same statement again. As per the question, 1U, which I'm representing as 1U dash, as per the question, we have to define this 1U as 1/24th. We have to define it as 1/24th of the mass of carbon to an atom. How did we define it? How did we define 1U? We defined it earlier as 1/12th of the mass of carbon to an atom. Now, as per the question, he's saying, let's define 1U as 1/24th of the mass of carbon to an atom. Right? How did we define 1U? We defined 1U as 1/12th of the mass of carbon to an atom. We defined 1U as 1/12th of the mass of carbon to an atom. This is how we defined it, right? I did not read the question yet. Just remember the procedure. As per the question, this is how you have to define 1U. As per us, this is how we actually define 1U. Let's do one thing. Let's call this as equation number 1. Let's call this as equation number 2. If I ask you, divide these two equations, you can easily divide them, right? Divide these two equations. It has to be dividing 1 by 2 or 2 by 1 or 2 by 1. Dividing second by first. It's going to be U divided by U dash. U divided by U dash is equal to mass of carbon to an atom. Mass of carbon to an atom cancelled. Here you'll get 1/12th. Here you'll get 1/24th. Right? So you got U divided by U dash is equal to 2. Or I can say U is equal to 2 times U dash. Do remember, whenever you see this sort of a question, this is the first step which you'll be always doing. Get the relation between U and U dash. Get the relation between U and U dash. Get the relation between U and U dash by just dividing these equations. After getting the relation between U and U dash, what next? What next, my dear students? Have a look. Have a look. As per our conventional scale is concerned, conventional scale means 1/12th of mass of carbon to an atom. This is the scale which we have chosen, conventional scale. As per the conventional scale is concerned, what is the molecular mass of carbon dioxide? Let me write it over here. Molecular mass of what? Of carbon dioxide. As per our scale, which we know. Carbon, its atomic mass is 12 multiplied by 1 carbon atom. Oxygen, its atomic mass is 16 multiplied by 2 oxygen atoms. The value comes out to be 44U. The value comes out to be 44U. But do we need to write the answer in terms of U or U dash? We have to write the molecular mass of carbon dioxide as per the new scale, as per the new scale, as per the scale that is given to us as per the question. So we are not supposed to write the molecular mass in terms of U. U is the conventional scale. We have to write it in terms of U dash, the new scale. The new scale. So can I say this 44U is nothing, it is just 44 multiplied by 1U? Absolutely. And already we know 1U is equal to 2 times U dash. 1U is equal to 2 times U dash. So the value has to be 88 U dash. This is the new molecular mass of carbon dioxide as far as the scale which was given to us as per the question. This is going to be the answer of the question. Perfect? Perfectly done, guys. I hope it is super clear to you. Similar type of question. Let's solve. Let's solve one more similar sort of question so that you can remember the approach from now onwards. Have a look, people, what I'm going to do. This is one more similar type of question. Give it a try now. If 1U is defined as 1/6 of the mass of carbon to an atom, as per the question, 1U is defined as, which I'm writing as 1U dash, as 1/6 of, 1U is defined as 1/6 of the mass of carbon to an atom. What about our conventional scale? Conventional scale says 1U is nothing, it is 1/12 of the mass of carbon to an atom. What is the first thing which we do? Let's call this as equation 1. Let's call this as equation 2. What is the first thing which we do? Divide the two equations. Let's divide second by first. If I divide second equation by the first equation, you get U divided by U dash is equal to 1/12 whole divided by 1/6. Mass of carbon 12, mass of carbon 12 cancelled. So you got U divided by U dash is equal to 6/12, that means 1/2. Or I can categorically say here, I can say, my dear students, I can say U is equal to U dash divided by 2. U is equal to U dash divided by 2. Right? Now since you got the relation between U and U dash, the question is done and dusted now. The question is done and dusted now. Quickly in the chats, what do you think should be the answer of this question? Quickly in the chats, everyone. Calculate the molecular mass of NH3 on new scale. So I would say the molecular mass of NH3. What is the molecular mass of NH3 as per our scale is concerned? Nitrogen, its atomic mass is 14 multiplied by 1. Hydrogen, its atomic mass is 1 multiplied by 3. The value after solving comes out to be 17U. This is the molecular mass of NH3 as far as the conventional scale is concerned. But we have to calculate the molecular mass of NH3 as far as the new scale is concerned, as far as this scale is concerned. So our answer should not be in terms of U, it has to be in terms of U dash. So you will write it as 17 multiplied by 1U. And already you know 1U is nothing, 1U is just U dash by 2. So it's going to be U dash divided by 2. The value comes out to be 8.5 U dash. This is going to be the answer of the question. Let me know quickly in the chats with the thumbs ups if you got to know how to tackle these sort of questions. Quickly, everyone. Quickly in the chats, everyone. Quickly in the chats, everyone. It must be clear to you. Yes, it must be clear to you. Will you be able to solve these sort of questions if they come in your NEET 2024 examination? Say yes or no in the chats. Say yes or no in the chats, everyone. Perfecto. Wonderful. Now let's move on to one more terminology. What is that? That is molar mass. That is molar mass. This is one more very, very important terminology, but at the same time, it's simple, right? At the same time, it's simple. Now have a look what this molar mass is all about and how do we define it. Okay, before defining the molar mass, have you heard about the term 1 mole? You would have heard about the term 1 mole in your class 9th as well. 1 mole of substance, 1 mole of any substance, 1 mole of any substance contains 6.022 into 10 raised power 23 particles of that substance. Do you know that? For example, if I say 1 mole of carbon, what does that mean? 1 mole of carbon, what does that mean? That means I am talking about 6.022 into 10 raised power 23 carbon atoms. Right? This is a marker, right? This is a marker. If I write 1 mole of marker, what does it mean? It means I'm talking about 6.022 into 10 raised power 23 markers. As simple as that. Correct? If I write 1 mole of ozone, 1 mole of ozone, what does that mean? That means I'm talking about 6.022 into 10 raised power 23 ozone molecules. Ozone molecules. As simple as that. Right? Perfect. Now people, understand. Understand. If I ask you, what is the molar mass of carbon? If I ask you what is the molar mass of carbon, what does that mean? That means I am asking you, what is the mass of 1 mole of carbon? Indirectly, I'm asking you, what is the mass of 6.022 into 10 raised power 23 carbon atoms? Whatever will be the mass of 1 mole of carbon, or you can say, whatever will be the mass of 6.022 into 10 raised power 23 carbon atoms, that's something which you call as molar mass of carbon. As simple as that. If I ask you what is the molar mass of marker, that means I'm asking you, what is the mass of 1 mole of marker? What is the mass of 6.022 into 10 raised power 23 markers? Whatever will be the mass of 6.022 into 10 raised power 23 markers, that's something which you will be calling as molar mass of marker. If I ask you what is the molar mass of O3, ozone, that means I'm asking you what is the mass of 1 mole of ozone? What is the mass of 6.022 into 10 raised power 23 ozone molecules? I hope you are getting it. So in short, if I want you guys to define the term molar mass, how will you define it? Molar mass, it is defined as the mass of 1 mole of substance. The mass of 1 mole of substance, number one. The mass of 1 mole of any substance. If you ask me, what is the molar mass of this jacket? I'll ask you, get me 1 mole of jackets. Get me 6.022 into 10 raised power 23 jackets. I'll calculate the mass of 6.022 into 10 raised power 23 jackets. Then I'll let you know what is the molar mass of jacket. Correct? Isn't it simple? Isn't it simple? Mass of 1 mole of any substance is what we call as molar mass of the substance. And let me tell you, it's expressed in, molar mass is expressed in grams per mole. Grams per mole. Right? For example, if I say 12 grams per mole, if I write the term 12 grams per mole, what does that mean? That means 1 mole of the substance has got the mass of 12 grams. If I say 14 grams per mole, that means 1 mole of the substance has got the mass of 14 grams. Right? I hope you're getting. Now let's try to understand everything a bit more in detail. For that, what I need to do here, I need to make certain space so that it gets clear to you properly. Mass of 1 mole of a substance is something which we call as molar mass of that particular substance. Now, dear students, I'm writing a statement. The statement is very simple. I'm writing molar mass of oxygen, O. Molar mass of oxygen, O. What does it mean? What does it mean? You need to answer. Molar mass of oxygen, molar mass of O. It means I'm talking about the mass of 1 mole of O. It means I'm talking about the mass of 1 mole of O. My dear students, the same statement I can write in a different format. 1 mole of O contains how many oxygen atoms? 1 mole of O contains 6.022 into 10 raised power 23 oxygen atoms. So instead of mass of 1 mole of O, can I write the mass of 6.022 into 10 raised power 23, which is represented by Na. Mass of Na oxygen atoms. Is the meaning of both the statements same? Absolutely. Either you call it as mass of 1 mole of O, or you can say mass of 6.022 into 10 raised power 23 oxygen atoms. Correct? Now the same statement which I wrote in this manner, I'll write it in a different format. Have a look. Mass of Na oxygen atoms. So how many oxygen atoms do we have? we have got Na oxygen atoms, and we are calculating the mass of Na oxygen atoms. Can I write it like this? Can I write it as mass of one oxygen atom? Mass of one oxygen atom. Just calculate the mass of one oxygen atom and multiply that with the Avogadro's number. Will be done. Why to do this much of work? Calculate the mass of one oxygen atom, multiply it with Avogadro's number. You will be getting the mass of Na oxygen atoms. That means you are getting the mass of 1 mole of oxygen. Mass of 1 mole of oxygen is something which you call as molar mass of oxygen. Isn't it simple? Now you tell me, I wrote a statement here. Mass of one oxygen atom. Just this thing. Mass of one oxygen atom. Mass of one oxygen atom means I'm talking about the atomic mass of oxygen. And what is the atomic mass of oxygen? You know, that's 16 AMU. So instead of mass of one atom of oxygen, I'm writing 16 AMU and I'm multiplying it with the Avogadro's number. This 16 AMU, you can further break it as 16 multiplied by 1 AMU. And over here, you have got Avogadro's number. Now, my dear students, if I ask you, instead of 1 AMU, what can I write? Instead of 1 AMU, what can I write? Instead of 1 AMU, can we write 1 divided by Na grams? Instead of 1 AMU, can we write 1 divided by Na grams? Right, we can do that. Instead of 1 AMU, we can write 1 divided by Na grams, right? And this is its own Na. So this Na got cancelled. The value came out to be 16. And this was 1 divided by Na grams. So it is 16 grams here. Now you tell me what is meant by the 16 grams. What were we exactly doing? We wanted to calculate the molar mass of oxygen. We wanted to calculate the mass of 1 mole of oxygen. And the mass of 1 mole of oxygen is coming out to be 16 grams. The mass of 1 mole of oxygen is coming out to be 16 grams. Right? What was the atomic mass of oxygen? That was 16 AMU. Right? That was 16 AMU, atomic mass of oxygen. Mass of one atom of oxygen. What is the molar mass of oxygen? That's 16 grams. Can I say, in order to convert atomic mass into molar mass, we are not supposed to change the magnitude. We are just supposed to change the unit. Just instead of AMU, write grams. That's it. Oxygen, its atomic mass was 16 AMU. Now its molar mass is 16 grams. So instead of AMU, you just have to write 16 grams. That's it. I hope you got it. Nitrogen. Its atomic mass is 14 AMU. If I ask you what about its molar mass, you will say it's 14 grams, nothing else. Right? I hope it's super clear to you. Let me quickly summarize all these things now. Have a look properly what I'm going to say now. Let me quickly summarize all these things. What just happened? Just a second, guys. What is happening here? Can't I write anything? Okay. Just a second, yeah. Okay, let me quickly summarize all these things now in detail. Understand and analyze things now. Now you will be properly able to differentiate different things. Have a look. For example, let me start again with nitrogen. Am I taking nitrogen in atomic form? Yes, I'm taking nitrogen in atomic form. I'm writing just N. I did not write N2, right? Now you tell me, you know its atomic number is 7 and this is 14, correct? Now I'm going to write few terminologies. First terminology, that's 14 AMU. Second terminology, that's just 14. Third terminology, that's 14 multiplied by 1.66 into 10 raised power minus 24 grams. Fourth terminology, instead of 14 AMU, I'm writing 14 grams. You tell me the meaning of all these four terminologies now. You should be able to deliver this. Come on, tell me. 14 AMU, what does it mean? Check whether nitrogen is given in the atomic form. Yes. So this 14 AMU is nothing. I will be calling it as the atomic mass of nitrogen. This 14, you will be calling it as relative atomic mass of nitrogen. This particular thing, you will be calling it as actual mass of nitrogen. Actual mass of nitrogen. This 14 grams, you will be calling it as molar mass of nitrogen. Molar mass of nitrogen. Or one more thing. Is nitrogen in atomic form? Yes. Instead of molar mass, you can use one more term. You can use gram atomic mass of nitrogen. Gram atomic mass of nitrogen. Now you tell me the meaning of these different things. Tell me the meaning of these different things. 14 AMU. That means this is the atomic mass. This is the mass of one nitrogen atom. This is the mass of one nitrogen atom. One nitrogen atom is 14 times heavier than one AMU. This is the mass of one nitrogen atom in grams. This is the molar mass of nitrogen. This is the mass of 1 mole of nitrogen. This is the mass of 6.022 into 10 raised power 23 nitrogen atoms. Right? Okay, one more thing. Let me not use the term nitrogen. Let me take nitrogen in molecular form, N2. I'm writing N2 now. You have to be clear with all the things. I'm writing N2. Now tell me, N2, I'm writing the first term as 28U, then I'm writing 28, then I'm writing 28 multiplied by 1.66 into 10 raised power minus 24 grams, and then I'm writing just 28 grams. Tell me the meaning of all these terms. Quickly, tell me the meaning of all these terms now. Everyone, people, quickly. Everyone. First of all, check whether nitrogen is in atomic form or molecular form. It's N2 now, it's molecular form, right? So, what is this term then? I would call it as the molecular mass of nitrogen, right? What about this 28? You'll be calling it as the relative molecular mass of nitrogen. What about this particular term? You will be calling it as the actual mass of nitrogen. You will be calling it as the actual mass of nitrogen, right? What about this particular thing? 28 grams. 28U replaced by G. What do I call this as? You will be calling it as the molar mass of nitrogen. Or nitrogen is in molecular form. Should I write this as gram atomic mass or gram molecular mass? Or you can call it as gram molecular mass of nitrogen. Am I super clear to everyone? Am I loud and clear? Am I loud and clear? Everyone? There is one homework question which I'm giving you, and I would want its answer in the comment section after the video ends. I'm writing C6H12O6, right? You are going to tell me, first question, its molecular mass. You are going to tell me what about its molecular mass. The second one, you'll be telling me its relative molecular mass. Third thing, you'll be telling me its actual mass. Fourth thing, you'll be telling me the gram molecular mass of glucose. These are the 4 things which you will let me know in the comment section of the video. Okay, perfect. All right. So I think all these 3 terminologies are clear to you, correct? If they are clear, then you have to answer one more question. If these are clear, then you have to answer one more question. And the question is like this. Let me frame a question like this. The mass of one atom of an element. The mass of one atom of an element is, let me keep it as, just a second. Yeah, 4 into 10 raised power minus 23 grams. Full stop, identify the element. Identify the element. I'm giving you the options. The first option is sodium. The second option is magnesium. Approximate answer I need. Third answer is iron. D is your Anything. Carbon. What do you think should be the answer of this question? The mass of one atom of an element is 4 into 10 raised power minus 23 grams. You need to identify the element. Will you be able to do it? What do you think? What do you think? Quickly. Quickly, my dear students, everyone. See exactly how we are going to solve it. It's a very simple question. It's a very simple question. See, let's say the element is X. Let's say the element is X. As per the question, the mass of one atom of X, how much is that? 4 into 10 raised power minus 23 grams, right? Mass of one atom of X is this much. What about mass of 2 atoms of X? I'll be multiplying this term with 2. Mass of 3 atoms of X, multiply this term with 3. Mass of 4 atoms of X, multiply this term with 4. Mass of Na atoms of X, mass of Na atoms of X will be 4 into 10 raised power minus 23 multiplied by Na, 6.022 into 10 raised power 23. Correct? If mass of one atom of X is this much, mass of Na atoms of X will be this much. So 10 raised power minus 23, 10 raised power 23 cancel. 6, 4 comes out with 24 grams. So what is this 24 grams? This is the mass of Na atoms of X. Na atoms of X means 1 mole of X. Na means 6.022 into 10 raised power 23 atoms of X, which means I'm talking about 1 mole of X. So mass of 1 mole of X is 24 grams. Mass of 1 mole of substance is something which you call as molar mass. That means you got to know the molar mass of X. You got to know the molar mass of element, that's 24 grams. Now among these 4 elements, which element has got the molar mass of 24 grams? If you remember, atomic mass of magnesium, that's 24 AMU. So molar mass has to be 24 grams. Done and dusted, right? Yes? Perfectly done? Perfectly done? My dear students, I think this much is enough for today. This was your first lecture of your NEET 2024 Chemistry with me, right? Perfect. Today only, I'll be taking one more session at 9 p.m. in which I have to talk about certain important updates, right? Some important announcements are there which I have to give you guys today at 9 p.m. Do not forget to attend that session. That's really, really very important. The ones who have joined the Avengers batch or the ones who have not joined the Avengers batch, everyone. If you are 2024 aspirant, if you are 2025 aspirant, if you are writing NEET for the first time or the second time, you guys have to come again on this channel today at 9 p.m. sharp. Okay, I have come up with certain important announcements which I have to deliver. Okay, perfect. Suresh, all these questions I'll be answering in the 9 p.m. session. So just stay tuned, right? So my dear students, this was all from my side in the tonight's session. I'll catch up in the next session. I'll let you know when is the next session of the Achievers batch, right? So if you're not liked the session yet, please do like the session. And whatever questions I gave you as the homework, I would want answers of every question. Okay? And do let me know in the comment section of this particular video whether you liked the session or not. Whether this session was beneficial for all of you or not. Right? As I promised, we'll be starting from the basics. That's how we are going to start every session on this particular channel. Right? So stay tuned and take care. Let's kill it this time. God bless you all. Bye-bye.